Welcome to another coding tutorial, and in today's video, I'm going to show you how to make these bubbly objects called metaballs using marching squares. The bubbly objects that you see here are known as metaballs and, according to Wikipedia, are not to be confused with meatballs. Metaballs are characterized by their ability to meld together when in close proximity to create single, continuous objects. And while researching on this topic, I came across a detailed write-up by Jamie Wong, which this tutorial will be based on. I will link his article below, and I recommend you checking it out. Before we start coding, let me first explain how we're going to approach this. So there are a total of two main components. The first one is a set of circles, and then the second one is a grid with a specific number of rows and columns. The algorithm that we're going to use is called marching squares, and marching square is an algorithm that generates contours based on a threshold value for a 2D scalar field, in our case, the grid. And you may be wondering, how exactly do we decide how to generate a contour and what threshold value to use? Basically, the contour or the outline that we want to draw is the outline around the set of circles on the grid. So we need to first know where the circles are on this grid. Because we're working with circles, let's start by looking at an equation of a circle. As you can see here, x and y are the variables for a point on the circumference of a circle. And this circle has a center of x0 and y0 coordinates and a radius r. To know whether the circle is on top of the grid, we need to modify the equation a little bit. So instead of just using an equal sign, we need to use a less than or equal sign. So it includes all the areas inside the circle instead of just the circumference. Now x and y would be the pixels on the grid, and we do the calculation to see whether that point on the grid is underneath the circle or not. This equation only works for one circle, but because we're going to be dealing with a set of circles, we need to do the same calculations for all of the circles and sum the value up together. What makes this algorithm efficient is that instead of doing the calculation for all the pixels on a grid, we're only doing to the four corners of each pixel of the cell. And if the calculation comes out to be more than or equal to the threshold or 1, we set the value for that corner to be 1, and if not, we set the value to be 0. And once we have the four values for each of the corners for each of the cells, then we map it to one of the 16 configurations to draw a specific contour. Let's start by drawing a circle. So I'm going to declare a variable x and set it to my mouse x location, and y to be mouse y location. And then I'm going to draw this circle. And this circle is going to take in four arguments, the x and y coordinate of the center of the circle. And I'm also going to declare radius to be 50. And the third and the fourth arguments of an ellipse function takes in the width and the height, or the diameter. So we need to put in r times 2 and r times 2 here. And all right, now we have a circle that follows my mouse. And then I'm going to draw another smaller circle at the center of the canvas. So I'm going to set it as px equals to 200 and py equals to 200. So because the size is 400 by 400, 200 by 200 is going to be the center of the screen. So let's draw this ellipse at px and py. Let's do a small diameter of 5. And I'm going to color it black and color my initial one. Actually, I'm going to do no fill for the first one. All right, now I'm going to create another variable called value, and this variable is going to be equals to the calculation to see whether the smaller circle is underneath or on the circumference of my bigger circle or not. So let me declare a variable called val. So val is going to be equals to the equation, which is r squared divided by px minus x, right, times px minus x and plus py minus y times py minus y. I'm going to put an additional parenthesis here. All right, and then I'm going to also just draw a text on top to display the value val here. So I'm going to do round because it's going to be a long floating point, long decimal point. So I want to round it to 2 decimal points, and I want it to be at the location px and py minus 10. So it's on top of the point in the center of the circle. So let's try this. All right, so as you can see here, the value is below 1, and once it reaches here, right, at the circumference, it's at 1, and then it increases as the circle is very much on top of the smaller circle, and then less than 1. All right, so this is for just one circle, right? So this is the equation for one circle. Now let's do a set of circles, but instead of doing everything on Sketch, I'm going to create a circle object. So I'm gonna come to this arrow here, click the plus sign, and then click create file. I'm gonna call it circle.js. Before we write the class, let's go to index.html file, and then copy and paste this line of code here. Change the word sketch here to the file name that you just created. In my case, it's circle.js, and this is a way for us to integrate a new JavaScript file into our program. So now let's go back to circle.js, and we want to write a class. My class is going to be called circle. And then in the constructor function, I'm going to declare 3 variables. So this x, and I'm going to set it equals to a random value between 0 and width. This y is going to be a random value between 0 and height. And I'm going to set a radius to be a random value between, how about 20 and 50. And then I'm going to write a method called display to draw the circle. So ellipse at this.x and this.y, and then this.r times 2 and this.r times 2. And then let's do no fill here. All right, so let's just try to see if this class works. So I'm gonna create an object called C, and C is going to be a new circle object, right? So now we don't need this variable r anymore, and we basically don't need these two either. So we're gonna do c.display, right? Okay, we're gonna put it here, and we don't need these two because this is essentially the display method. All right, but if we click play, we get an error because now we don't have x and y values here. So we need to change this to c.x and c.y to calculate using the x and y coordinates of the circle object. Okay, let's try that. R as well. All right, and it's not moving because now it's not tied to my mouse anymore, right? But if we just keep playing, it does exactly what we did before. Why don't we write another function called move? And move is going to be a method that moves the circle. I'm going to set 2 new variables called dx and dy, which are going to be the direction that we're going to move the x and y coordinate of the circle. So dx, let's do 2, and dy, let's do 1. And so to move this, we need to basically just add this.x with this.dx. This.y is going to be plus or equals to this.dy. And let's try this, but we need to call the method first. So c.move. All right, and it just moved off the screen. So we also want to add one more thing, which is to check the boundary so that it bounces back when it hits the wall. So we can do that by doing an if statement. If this.x is more than or equals to the width, or this.x is less than 0, then we want to set this.x to be the opposite value of what it originally was. So it will go either between 2 or -2. So when it hits the border, then it changes the direction. And we do the same thing for the y direction, so more than or equals to height, or this.y is less than 0, then we change the y direction. All right. As you can see here, the value becomes 1 or more than 1 when the circle is on top of this smaller circle. But we don't want to deal with just one circle. We want to do a set of circles. So let's create a set of circles. So let circles be an array, and let's create a new variable called num, and num, let's set it to 5. So num is going to be the number of circles that we want to create. And then we're going to write a for loop that loops through I equals to 0 to I less than num. And we're going to populate the circles array with new circle object. Now we need to call another for loop. And this for loop is going to go through the same thing, right? So the first thing that we need to do is that we need to recalculate this value. But instead of just doing this one calculation, we want to add all the calculations that we do for all of the circles inside this variable val. So first, I'm going to copy and paste this line of code inside the for loop. And then we want to reset this value to 0 every single time, right? Because we want to recalculate the locations of all of the circles every time we call the draw function. But instead of this equal sign here, we're going to do plus equals. So now the values is added, the calculation that we do to all of the circles. And instead of just C here, we need circles of I for all of these. All right, and then I'm gonna actually write another for loop of the same for loop to call these two functions. You might be wondering why we need a different for loop because we already have this one, but you will see why in the next step. All right. Okay, so you can see that the values go up a lot when all of the circles are near or on top of this point here. One thing that I want to add before we move on is that instead of setting the color to black, I want to write a conditional statement that says if val is more than or equals to 1, then set fill to green, else set fill to black. And then I'm going to move this here. All right, let's try that. Oh, it didn't do anything. Oh, we need to erase this. All right. So now when the value is above or equals to the threshold, then it changes the color to green. Perfect. Now, we don't want just the point in the center of the canvas. We want to draw a grid of a specific number of rows and columns and a specific size. So first, let's declare columns, rows, and size. Let's set size to 50, and then I'm going to create an array called grid. This is going to be a 2D array. And then now we can delete the px and py. And then I'm going to calculate what the columns would be. So width divided by size, and rows is going to be height divided by size. And then we're going to write a nested for loop that goes through the columns and rows, right? So first we want to populate this grid array with empty arrays with the number of columns. Then in the inner loop, we're going to go through the number of rows, and then we're going to initialize the value. So this has to be j. We're going to initialize the value to be 0, but the grid to the array essentially is going to be storing the values that we calculate here. All right. So now that we have a 2D array called grid with the initial values of 0, now we want to do the same thing here by writing a nested for loops. And as I said, right, basically we are going to calculate this. So I'm going to put this in here. So now we are going to go through all the cells inside this grid. And then we're going to calculate the value here. And then we're going to store this value inside the grid. But we also need to modify this px and py because now it's going to be, what is it? It's going to be I times size and j times size, right? Which is the location of the x and y coordinates of the top left corner of each of the cells. So this is going to be I times size and then this is j times size. So as I said before, instead of calculating the values of all the pixels inside the grid, we choose to calculate just the corner of each of the cells, right? But the corner that we pick is the top left corner of each of the cells. But because this grid is a set of rows and columns, we get the calculation for all of the 4 corners. Okay, and then let's just click run just to make sure that everything is okay. We're also going to move all of this inside here. And then instead of px and py here, it's going to be I times size and j times size, right? And I also want to draw a rectangle to show the grid as well of the size and size. And then this is going to be I times size, j times size. Let's try that. Okay, we need to change the colors a little bit. Okay, and then these will have to be before this conditional statement, right? That changes the color of the corners. Okay, something is wrong because all the values are the same on each row. So maybe let me just check real quick. So for this nested for loop, I need to change from I to k now, right? Because now we have 2 nested loops. Then all of the i's here will be k to call each of the circles inside the circles array. K, 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 K. All right. Alrighty, let me just stop moving the circles for now. Okay, so as you can see here, all of the green circles here are the ones that are underneath the bigger circles, right? But as you can see, we're missing some corners of the cells on the most right columns and the most bottom rows. So we can easily fix this by just add 1, 2 columns and rows here. All right, so now we basically add another set of columns and another set of rows so that we get the top left corners of each of these cells. Now that we have the calculated values for all of the 4 corners, we want to write a conditional statement that says, hey, if the value is more than 1 or all of these cells that have the green values, then we want to set that corner to be 1. And if not, we want to set the corner to be 0. So I'm going to write another nested for loop. And this nested for loop will go between 0 to columns minus 1, right? Because now we have an extra column and an extra row. For let j equals to 0, j less than rows minus 1, j plus plus. And then I'm going to declare 4 variables, a, b, c, and d. And a is going to be the top left corner, b is going to be the top right, c is going to be the bottom right, and d is going to be the bottom left. So let a equals to 0. Initialize it at 0 first. I'm going to also create 4 more variables. So f underscore a is basically the values here, the values from the calculation. So f underscore a is going to be grid of I and j. Let f underscore b equals to grid of I plus 1 and j. So this is the top right corner. F of c is going to be grid of I plus 1 and j plus 1 because it's going to be the bottom right. And f of d is going to be grid of I and j plus 1. And this is the bottom left. Once we have this, we can write a conditional statement. So if f of a is more than or equals to 1, then set a to be 1. Else, a equals to 0. And then we basically want to write this set of conditional statements 4 times, right? For b, c, and d. Okay, so basically each of the corners will have a number, either 0, 0, 0, 0, 0, 1, 0, 0, and so on. There are a set of 16 configurations. But instead of using this 0 and 1's values, which we called binary, we're going to convert the binary value to a decimal value, so that instead of getting the value 0, 0, 0, 0, we want to set that equal to 0. And if it's 1, 1, 1, 1, we want to set it to 15. So I'm going to create a new variable called config. We're going to convert from binary to decimal, and we're going to use the equation 8 times a plus 4 times b plus 2 times c plus 1 times d. So now from the value of 1s and 0s, now we're going to get a value between 0 and 15. To map it to one of the 16 configurations, we can use a really long set of if statements, and that's going to be really long and quite tedious. So let me show you a different syntax. So we can use a switch statement. And switch basically take in a specific case that we want to do, right? In our case, it's going to be a case that is between config equals to 0 or config equals to 15, right? And then we just write the word case. If it's 0, then do a specific command, then break, meaning get out of this whole switch loop, right? And basically we need to do 15 of these. So it's still quite a bit tedious, but maybe a little bit less, I don't know. Okay, 1, 2, 3, 4. Okay, so we have 1, 0 to 15. So now we need to put in the arguments inside the line function, right? And the line function takes in a total of 4 arguments, which is the 2 sets of x and y coordinates. As you can see from this configurations, we're basically drawing a line between the midpoints. But the midpoint, which midpoints? It depends on which configuration. For example, for case 0, we don't need to draw anything. For case 1, we need to draw between this point here, the bottom one, and the left one. So I'm going to call these point 1, which is between corner A and corner B. Point 2 is between corner B and corner C. Point 3 is between corner C and corner D, and point 4 is between corner D and corner A. All right. In case 1, we need to draw between point 3 and point 4. So we're going to first declare these points, right? And I'm going to declare it as a vector. And a vector is an object that holds 2 values. So it's going to hold an x and y coordinate of this point. And you can create a vector by using this built-in function called createVector. So it's going to be x times size plus size divided by 2, right? Because it's going to be in the middle here, and then j times size. And then we're going to calculate point 2 to point 4. So point 2 is going to be this point here, which is I times size plus size, right? Because it's going to be here, and then j times size plus size divided by 2. Then 0.3, which is the middle here, is going to be I times size plus size divided by 2, and then j times size plus size. And then the last point, which is 0.4, is going to be I times size plus, no, just I times size, and then j times size plus size divided by 2. All right, so for case number 1, it's going to be between 0.3 of x, 0.3 of y, to 0.4 of x, and 0.4 of y. And I'm going to comment all this out for now, just to show you. Point 3 is not pt. All right, so you can see this cell here, and also this one, has the bottom left corner that is green, right? And that is configuration 1. And we basically just do the same for all of the 16 cases. But instead of doing this and take a long time, I'm going to magically do it like this. All right, so you can just look at my code afterwards. Okay, so now we have the contours that we want. And now let's try first reduce the number of the values of size here, so it has a higher resolution. Wow. Okay, and then I also want to comment out the circles here. Actually, we can keep the circle. We don't need the text. We want to move it as well. Then maybe we can comment out the rectangle. Let's try that. And there you go. Okay, so I'm going to also comment out the ellipse here. And as you can see, like even if we reduce to, like, let's say 1. Wow, it's very slow. Okay, let's do 5. It's pretty blocky looking, which is its own aesthetic, and I think it looks pretty cool, but it is because we're drawing the lines from the midpoints of each of the cells, right? But if we want to make the contour a little bit smoother, what we can do is that we can use a technique called linear interpolation. And essentially, instead of just putting the point at the middle between the two corners, we can actually calculate which location that point should be based on the magnitude of the calculation that we did in the earlier step that gives us the floating values on each of the corners. The main idea is that, let's say we have a circle that is half or even 3/4 inside a specific cell on the grid. The current implementation is that we would draw a line from the midpoints here, whereas with linear interpolation, we would be calculating the locations of the points based on the magnitude of the calculation that we did in the previous step. And this will give a more accurate contour because it will move the points based on where the circle is on the grid. We'll be using a built-in function called lerp, which takes in a total of 3 arguments, a, b, and amt, or the amount, where in our case, a and b will be the locations of the two corners, and the amount is going to be calculated using an equation 1 minus f of a divided by f of b minus f of a, where f of a and f of b are the f underscore the corner values, right? And we have created the variables for that already. So let's implement that. So these are the values of f of a, f of b, f of c, and f of d, as I mentioned earlier. So let's comment these points out. Let's start with point 1 again, right? And we're gonna create a vector. And I'm not gonna put anything inside here because I'm going to set the values afterwards. So let's start by calculating the value amount, and this amount is going to be, this is the point between point A and point B, right? So the amount is going to be 1 minus f of A divided by f of B minus f of A. And then the x coordinate of this point will be the lerp function, and we're gonna put location of the point A, right, which is going to be I times size. And then point B will be I times size plus size. And then the amount will be what we have just calculated here. And the location of the y coordinate will just be j times size. All right, and then we're gonna do the same thing for point 2. Then amount will be, so this one is gonna be between point B and point C, right? So it's gonna be 1 minus f of B divided by f of C minus f of B. And then now it's gonna be the reverse. So point 2 of x will now be set to I times size, right, between A and B, plus size. Pt of y is going to be lerp of j times size plus size, and the amount. Then let point 3 equals to create vector. Then the amount will be, so even though we do A, B, C, and D, we goes from left to right, top to bottom. So it's going to be 1 minus f of D divided by f of C minus f of D. And then point 3 of x, same thing as this, right? Similar here. So lerp of I times size plus size, and then the amount. And then let point 4 is gonna be, oh, and then we need pt 3 of y. So this is gonna be I times size plus size, right? Because it's gonna be the location. The y location is gonna be at the bottom. Sorry, this is j times size. All right. And then the last point is going to be 1 minus, so it's going to be between point A and point D, but we go from top to bottom, so it's going to be f of A divided by f of D minus f of A. And then point 4 dot x is going to be equals to I times size, right? Because it's going to be on the left side. And then for y, it's going to be the lerp function between j times size plus size, and then the amount. All right, let's hope that I did this correctly. Let's play. Yay! It's so much smoother now. Let's just try to make it lower resolution just to see if, yeah, not too bad. Even if we put the lower resolution, it still looks pretty smooth. So these are your blobby objects using the algorithm called marching squares. I might actually look into how to implement the marching cubes. So if you're interested, let me know in the comments below. And if there are other algorithms that you want me to explore, let me know as well. But give this one a try.